Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various questions that may arise in the question bank of data management and representation subject. So for that, the very first question is that explain the presentation of data using tables is the one. So actually the presentation of the data is going to be classified into two categories like tabular presentation and visual presentation. And again this visual presentation is going to be divided into further two types like graphical presentation and diagrammatical presentation. Right, so the presentation data where you can able to represent in the form of tabular one is the thing, and then where you can also represent in the form of visual representation. So the visual representation again where you can able to represent through the through graphical means where you can able to represent through graphs, and diagrammatic representation means where I can able to represent through diagrams. So some of the graphs like bar graph and then line like this, and bar diagram and then line diagram and then pie diagram like this, and here also bar graph and then like this. Then so what are the various principles what you have to be followed before the presentation? So for that what you have to do is, so the data what you are going to do, so that should be presented in the form of simple form, and then all the time you have to create some interest in the reader. So what the data we are presenting, and then it should be also concise but without losing its important details, and also facilitate the further statistical analysis, and should also define the problem which should also suggest its solution, right? So the principles of presentation will be that, so all the time what the data we're presenting that should be in the form of simple one, and then all the time what is the data we're presenting that should able to create some interest in the reader, and it should also be concise but without losing its important details, and it also facilitates the further statistical analysis, and we should also define the problem what the solution is. Tabulation, so already many of the people know that how the tables will be should be in the form of rows and then columns. So the definition is that it should be a systematic and logical arrangement of the classified data into rows and columns, right? So it should be a systematic and logical arrangement of classified data into rows and then columns. Suppose if I'm going to take the sports as one column and people as another column. So the sports what we know actually snooker, tennis, gymnastics, swimming and track like this. And how many number of people are going to be participated in the snooker game, and how many number of people are going to be participated in tennis like this. So next, what are the significance of this table? So the significance of the table is that it should always simplifies this complex data, and unnecessary details and repetition of what is there in the data that should be avoided, and then it should also facilitate the comparison easily, and it also gives identity to the data, and then it also reveals the pattern within the figures which cannot seen in the narrative form, right? So the significance of the tabulation is that all the time we are able to simplify the data, and then unnecessary details and the repetition of the data is going to be avoided, and also facilitate the comparison quickly, and should also give the identity of the data, and it should also reveals the pattern to the figures which cannot be seen in the narrative form. And what are the rules we have to be considered for the tabulation? So for that, the number should be assigned to the table. That should be table number have to be specified, and the title should be given to the table. So it should be the concise and then should be self-explanatory. And the contents of the table should also be defined clearly, and subtitles should be properly mentioned without columns and rows. And the group intervals in rows and columns neither be too narrow nor too wide. They should also be mutually exclusive, and the unit of measurement must be mentioned clearly wherever necessary, and any forms and signals that is there, so if used, should be explained in the footnote. And no place should be placed at the left of the body of the table, and there should be logical arrangement of data in the table. So these are some of the rules and regulations what we are going to be follow in this tabulation. So that whatever the table you are designing, that the number should be given first, or then the table should be concise and self-explanatory way, where the contents of the table should be defined clearly, and then the subtitles what they propose that should be mentioned clearly with rows and columns, and the units of measurement should be mentioned clearly, and then any short forms or symbols should be used in the explained food way, and no place should be left in the body of the table, and there should be logical arrangement of table in the data in the table. So this is the simple view of the table, how it will be. So the title where you can able to write here, and the table number you have to mention this, and the row heading and column headings, and then some other column, and then rows entries we can able to write it here, and then footnote and so where I can able to get this data can be write it here. And the next one is precautions. So the precaution is that the table should be suit the size of the paper, and then captions and stubs, whatever should be arranged, that should be in some systematic order should be have to maintain, and the units of measurement should be defined clearly, and then in the given table as well, and the figures should be rounded to avoid unnecessary details that in the table, and footnote to this effect should be given. Right. So these are some of the precautions what have to be followed here. And the next one is that explain different types of tables for the data presentation. So just now I said what is the table and what are the rules and significance we have to be take care for designing the tables. And then next one is that what are the different types of tables what we are having here. So for that the types of tables are again classified into two types, like based on the purpose and based on the content. So based on the purpose is that reference table, and then text table is the thing, and based on the content means it should be a simple table and then complex table. Again, this complex table is going to be divided into a double table, triple tables, and multiple tables, right? So the types of tables are broadly classified to one. So first one is the purpose. So purpose means the reference as well as the text table, what we call, and based on the content, if you are able to divide it into tables like simple tables and complex tables. Again, this complex tables is divided into table, double table, triple, and then multiple table. So very first thing is the reference table, what we can have called other name as general purpose or primary tables. These tables can able to represent the original data for the reference purpose, and it should also contain the absolute and actual figures and round numbers or percentages, right? So the reference table is thing where can able to represent this original data for the different purposes. Okay, and it also contains absolute and actual figures and then round numbers or percentages. So other names of this reference table what we call it as the general purpose or primary tables as well. So the table representation of the data will be like this. So if I'm going to take one table here, so what he thinks, so this should be the table number, and then this should be the table title, and then this should be the column headers, and these and all will be the rows, and that thing what we call it as a body here, and this is the source node of the table. And next one is that a text table. So text tables, so we can able to call it as special purpose or derivative tables. So that should be constructed to present the select data from one or more general purpose tables. It brings out a specific point of answer to question, and it also includes ratios, percentages, and averages. It should be found in the body in the text. Okay. So the text tables is the thing where you can able to construct to represent the selected data from one form to the more general purpose tables. So it brings out the specific answer to the specific question, and it also includes the ratio, percentages, averages, and it should be found in the body of the text. And next one is that simple tables. Again, the simple table is that so the data which is relating to one characteristic, then we have to go for the simple table. Suppose gender. Suppose gender is there means boys and girls, and number of students that should be either and 9 or it may be 29th number of girls for this. And then suppose the gender is going to be related to only one characteristic, then you have to go for the simple table. So double table means we have to go for the double characteristics. Suppose for the same gender I'm taking here, boys and girls. In this food habit I'm taking how many number of boys are vegetarians and how many number of girls will be the non-vegetarians. Like this I want to find out, so I want to distinguish between the two characteristics among the two variables. At the time I have to go for the double table. And next one is the triple table. So triple table is a thing where the data is going to be related to three characteristics. So same thing, I'm taking gender here, boys and girls, and within that food habit, again I'm taking vegetarians and non-vegetarians. Again within that vegetarians, so how many number of people that whose age is less than 20, how number of people whose age is greater than 20. Similarly, non-vegetarians less than and non-vegetarians greater than 20 years. Right? So this one characteristics and this other characteristic and this other characteristic. So three characteristics I have taken, right? So at the time what I have to do, I have to go for the triple table. Then multiple table. So what is the multiple table here is, so up to here we have seen this. Suppose if I'm going to further divided of this one. So right, so where the column is going to be divided into two, as well as the rows also going to be divided into two. At the time I have to know this multiple table. So here the same example what I did is, so gender is taken, so boys and girls. Again these boys and girls will further divided day scholars how many and hostelers how many, right? At the same time, the vegetarians will be how many number of people 20 and how many number of people greater than 20, similarly non-vegetarians. So this kind of information if I want to represent through simple tables is not possible. This kind of structure what we can able to call it as a multiple table. Explain the presentation of data using the graphic is the next question. So up to now we have seen how the data is going to be presented through tables. Now graphs we will see now. Presentation of data. So this presentation of data through graphs will be here as histogram, frequency curve, frequency polygon, and then occurs line graph. So these are the graphs, and diagrams will be bar diagram and then pie diagram. So again, this bar diagram is for the transfer simple bar, multiple component, it's percentage and deviation bar diagram like this. Right. So the presentation of data, so that should be divided into two ways. So one is through graph and another is through diagrams. So these diagrams will be of two types like bar and pie diagram. So this bar diagram is again divided into simple bar, multiple bar, component bar, percentage and deviation bar. The graphs will be that histogram, frequency curve, frequency polygon, occurs and line. Then advantages. So when it comes to advantages of these graphs will be, so they are attractive one, and they give the board's wide view of the data, and they can easily understood by common men, and they can able to facilitate the comparison of various characteristics, and impression created by them are long lasting, and theorem and results statistic by visualized using the graphs. So this is the figure of board's view. So how the board is going to be viewed entire thing at a single shot, right? Board's view. So how it will be single shot, the eye can able to see entire thing at a time. So that's why the advantage is that the bird's eye view of the data, and then the attractive is the thing, and then can also easily understood by common men. Even uneducated people can also be understood what the data it is, and then it facilitate easy comparison and also various characteristics, and then impression is going to be created long lasting, and theorems and results of statistics can be visualized using the graphs. The limitations. So the limitations means they are visual aids, so they cannot be considered as alternatives for the numerical data. And through theories and results, it could be easily visualized by diagrams and graphs. and mathematical rigor and cannot be brought in. So the diagrams and graphs are not accurate as tabular data. Only the tabular data can be used for further analysis. So by diagrammatically and graphical mispresentation, observers can be misled easily. So it is possible to create the wrong impression using the diagrams and graphs. Right? So the graphs and diagrams is the thing where you can able to represent several things, but we have to follow some limitations. So all the things will be of visual aids and cannot be considered as numerical data. And through theories and results, it cannot be easily visualized by graphs and diagrams or graphs. All the graphs and diagrams are not accurate as tabular data. Only the tabular data can be used for further analysis. And by diagrammatic and graphical representations, so it is not possible. It is possible to create the wrong impressions as well using the graphs and diagrams. Next, what are the rules we have to be considered for drawing these graphs and diagrams? So, the first thing is that choose the form of the diagram or graphs which is capable of representing the given set of data. So, the first thing is the title, so which gives the information of diagrams or graphs contain, and scale. Selection of scale should be neither too small and neither too large, and neatness should be maintained, and then attractive, which can able to represent different types of lines or shades or colors, can be easily to make pictures more attractive, and originality, so which helps the observer to see the details with accuracy, and simplicity means good diagram should be depend upon easy, where where the observer can able to interpret it, and economy is nothing but the cost and average should be exceed drawing a diagram. Right, so these are the rules what have to be follow for drawing the graphs and diagrams. So first we have to choose this diagrams and graphs which should be capable of representing the given set of data, and we should also the information what it has given uh, should also be given title that should be able to call, and the scale should be maintained. The scale should be neither too small and neither too large, and the neatness should be and attractive should be, and originality should be also maintained, and the simplicity and economy. So these are the rules what you have to be followed. Normally, what are the difference between the graphs and diagrams is the thing. So for that we have to construct a graph or graph paper is generally going to be used where the diagram is not going to maintain, and that thing we have to maintain in plain paper only, and the graph which represent the mathematical relationship between the two variables, whereas the diagram does not. The graphs are more appropriate than diagrams to represent frequency distribution and time series. Diagrams are more attractive to the eyes and as such are better suited for the publicity and then propaganda. And the diagrams do not do anything to meaning of the data, and hence they are not helpful in analysis of the data. So the graphs are very much used by the statisticians and research workers in their analysis. So these are the things, some of the little bit differences, but we maintain between the graphs and then diagrams, right? So for the graphs, what you have to do is, so in order to construct that, so the graph should be maintained in a graph paper, whereas this diagram on a plain paper is sufficient. So the graph represents the mathematical relationship between the two variables, whereas the diagram does not. So and similarly, the next one is that the graphs are more appropriate than the diagrams to represent the frequency distributions and time series, and this is not possible through the diagrams. So diagrams are more attractive to the eyes, as such better suited for this publicity and propaganda. And the diagram do not add anything of meaning, and they are not helpful in the analysis of the data. And the graphs are very much used by statisticians and research works in their analysis. And next is that, so explain different types of techniques that are available for presenting data using graphs. So for that, we are having first one is that histogram. So histogram is going to be represented by set of rectangular bars, and variable is nothing but a class that is going to be taken on x-axis, and frequency is going to be taken on y-axis. So with the class intervals as the base. The rectangles with height proportional to the class frequency is going to be drawn, and set of rectangular bars so obtained should use the histogram. The total area of rectangular histogram represents the total frequency, and if the frequency distribution has an inclusive class interval, they should be converted into exclusive type. So the mode of distribution can be obtained from the histogram. Right? So the histogram is the thing. So how can I able to represent through the variables? You have to take it on x-axis, and then frequency is going to be taken on y-axis. So here, I have to maintain the class intervals here. So normally the values are not maintained. The class intervals is the thing we have to maintain the histogram. So the mode of frequency what I get here should be done in the form of the histogram. Next one is that using a histogram. Suppose using the how to construct a histogram here for that. So I'm taking heights and frequency as the column, and within the height I'm taking the class intervals as 150 to 145 to 150, 150 to 155, 155 to 60, and these are the frequencies what I got. So based on that I have to construct. So first is the class interval first one 145 to 150, and 150 to 155, 155 to 160, like this. Once I created, so within this class interval, what is the frequency here 2? So then I have to draw this. And next one is 5. So without main giving the gap, you have to give this. And next one is 9. So without giving the gap, you have to do this. Like this, I have to construct the system. So the mode of distribution can be obtained from the histogram. So the mode in the middle of this histogram, what is there, that should be more we can able to estimate it. And the frequency curve. So frequency curve means here the variables is going to be taken on x-axis, and the frequency I'm going to take on y-axis, but the frequencies are going to be plotted against the mid-class mid values, right? So the curve that we obtained is thus frequency curve. So normally the total area under the frequency curve represents the total frequency here. So the frequency curve, so the variables in the frequency curve is going to be taken on x-axis, and frequencies should be on y-axis, and the frequencies are going to be plotted against the mid-intervals, and these points are going to be joined by the smooth curve. So how can I able to construct this one is, so once I draw this histogram, so first I have to construct this histogram. So after constructing this, we have to join all the midpoints of this. Then only the frequency curve can be obtained. Suppose take it of the previous example. So if I'm going to take the once I constructed how to construct the frequency curve, so join all the midpoints of this rectangles, right? So once you take this, once you join all this, the curve what I obtained is nothing but the frequency curve. See here. So this is the example what I'm taking. So under this, the marks obtained should be between the class intervals. I'm taking 10 to 20, how many, and 20 to 30, 30 to 40, 40 to 50. A number of students who got that should be I'm taking on y-axis, right? So once I constructed these bars, so after joining the midpoints of each rectangle bar, so the curve what I join, what I get in, that should be the histogram. Sorry, that should be frequency polygon. The frequency polygon, if I'm going to take, right, so the variables is going to take in along the x-axis, and frequency same thing I'm taking on y-axis, and the frequency curves that should be plotted against the class mid values, and these points are going to be joined by the straight line. So first the figures who obtain the frequency are the polygon, and total area of the frequency represent the total frequency, right? So here, what is the difference between frequency curve and frequency polygon is that, so if I'm going to join through normal curve, so this should be considered as the frequency curve. Suppose if I'm going to join all the lines through a straight line, that should become able to call it as a frequency polygon. So see the example. So salary, I'm taking class intervals in between that and how many number of are there. So for that I have to construct this. So this is the histogram. Initially I constructed. So once I join all the midpoints of this, right, then I can able to get the frequency value. Ogives is another form of representing this. So ogive is the smooth graph with the cumulative frequency plotted against the values of the variable. And the class limits are going to take on x-axis and y-axis. And there are two types of ogives: less than ogive and the greater than ogive. So less than curve, what we can able to call it as negative ogive and positive ogive. So less than cumulative frequency curve. So that thing, the variables values is going and class will taken on the x-axis, and along the y-axis the value should be less than cumulative frequency, and these points are going to join the smooth curve that should be the less than ogive curve, and greater than ogive, same thing. I'm going to take x class limits on x-axis, and y-axis should be greater than the cumulative frequency, and what the points join that should be able to call it the greater than ogive, right? So ogive looks like this. So this should be less than ogive. Suppose less than means I can able to construct in this way one curve, and more than ogive, what is get should be this, right? So I'm taking the class intervals and x-axis as marks and number of students and same thing, right? So the less than ogive is the values whose the values is less than the cumulative frequency, and greater than ogive is the curve that should be obtained greater than the cumulative frequency, what we can able to. So intersection point is also be obtained through that. So that intersection point what we obtain should be called, able to call it as the median, right? So once I draw on this less than ogive and greater than ogive, so some two curves are going to be intersect at one point, right? So that point I can able to call it as the median of this. Let it be 43 something. And next one is that line graph, so which can also be called as time series graph. Normally, this kind of graphs mostly seen in cricket matches, what we are training like. So the line graphs are going to be used to display the comparison between the two variables, and which are going to be plotted on x and y axis. And x axis represents the measures of time, while the y axis represents the percentage or measures of the quantity. So they organize and present data in a clear manner and shows the relationship between the data, and the line graphs are going to display change in the direction. So it also shows the trend of event occurring over a period of time to know whether it is increased or decreased. So example, cancel details I want to present through line graph, I want to show it. Let me see the example. Suppose the duration of admissions I'm taking as a day 1, day 2, day 3, day 4, and the number of foreign heat. How many number of people having in day 1 foreign heat and day 2 foreign heat, like this. So in day 1, so the number of people's foreign heat value is 101, and day 2 it should be increasing 102, and day 3 it is decreasing 100.9 something, like this. So once I draw, I can able to get a line that should be able to call it as the line graph. So this is another view of line graph example shown on the application. So the retail prices of the petrol and diesel along with the price of the crude oil. So by seeing this graph, what can I able to understand that? So the Indian crude and this green black color is that diesel, and yellow is the petrol. So how the crude oil will be in 2004, and how the crude oil will be in 2018, how the petrol rises, and then petrol rates and diesel rates, how like this I can able to compare through the line graph as well. And next one is that explain different types of techniques that are needed for data presentation using diagram. That will is the next one. So here we're having different types of diagrams. So for the first one is the pie diagram. So this pie diagram is also called as a sector diagram, which can able to represent a discrete data of the qualitative characteristics such as blood groups, RH factor, age group, sex groups, causes, mortality, and then social group in population. The frequencies of groups are going to be shown in circle, and degrees of angle denote the frequency and area of sector. It gives the comparative difference as well, and the size of each angle is calculating by multiplying this total frequency by 360 degrees. So this is the pie diagram what I can able to get it here. So that should be sector diagram. So present the frequencies of the groups is going to be shown in circle, and degrees of angle denote this frequency and area of sector. So it gives the comparative difference at glance. So the size of angle is going to be calculated by multiplying the frequency. So entire thing, so just we draw a circle. What are the steps you have to be followed for drawing these pie diagrams for that? So first draw a circle and find the center of that and draw the radius and take a protractor and make use of calculators. So initially we know uh, the circle should be of 100% of data. The tuition fees will be 62%. Room percent is 17, room 10%, books 3%, transportation 8%. Like this. So once I get from this, identify the 62%, and from this 17%, 10%, and 8% and 3% tuition. So how it will be? Like this, I have to total sum should be 100%. See one example. So what is your favorite color? So favorite color is blue, yellow, green, red, purple, and other frequencies I'm taking. Then how I'm going to calculate this degrees from this data from that. So for that what I have to do is, so I'm taking blue here, and for the sequence is 6. So total should be 40, right? So how can I able to get the 40 means? So 60 divided by 40. So that should be 54 degrees centigrade. Similarly, yellow, how much will it be? 10 divided by 40, 900, 300. So like this 36 and 45, 72, 63. If I go into sum of that, the entire thing should be 360 degrees. So we can get suppose 60. So what 60 by total frequency is 40 into 360. So then I can able to get this 54 degrees centigrade. So like this from the data I can able to get degrees first. So once I got the degrees, then make use of this protractor and have to construct this eye diagram that is blue color, and then 90 degrees make it, and then make it as yellow color like this. So this is the way of constructing this eye diagram. So this is another example where I can able to construct with colors also can able to represent it. And next one is the bar diagram. So bar diagram, or you can able to call it as bar chart. So the bar diagram is consists of a series of rectangle bars of equal width. So either it may be in the form of horizontal bar, or it may be in the form of vertical bar. So the bars that stand at common baseline with equal gap between one bar and another bar. So if I'm not going to maintain this, then it should be called as histogram. If we maintain this, then it should be a bar diagram. So and all the bars will be constructed in such a way that their lengths are proportional to the magnitude. That should be the frequency here. So make a note that in bar diagram, the bar diagram should not space should be maintained base between the two bars, and equal bars should be of equal length. And first thing here we're having different types of bar diagrams like simple bar, and simple bar is the thing which is going to represent when items have to compare with regard to single characteristics, and the items are going to be represented by rectangle bars of equal width and height proportional to magnitude, and the bars drawn on common bases with equal distance have consecutive bars, and the bars may be shaded. So this is the simple bar. So common number of people are purchasing apples, oranges, banana, kiwi fruit, blueberry, and then. So this is the example of bar graph or bar diagram. Right. So these are the thing we are able to present the simple bar diagram. And similarly, how many number of people are going to school through bicycle, bus, car, walk, scooter, and train. So for that, I can also represent in the bar diagram. So this is another example of presenting the bar diagram. So again, this bar diagram can be further divided. That one you can able to call it as a component or stack or proportional bar diagram. Okay. So this proportional bar diagram is the thing where within the bar itself we can able to divide it into further categories. So that should be black. So this purple is going to indicate group O, and green is going to be represented group AB, and red is for group B, and this for group A. So these are the some of the simple view of this stacked bar or proportional bar diagram. So here the data will have the items whose magnitude should have two or more components, and items are going to be represented by rectangle bars of equal width and a height proportional to the magnitude. So the bars which is going to be divided so that the subdivisions in height represent the components. So to distinguish these components from one another clearly, with different shades are going to be applied within this to make the comparison between that. So the component bars are drawing when the comparison of total magnitude along with the components is going to be required. So suppose I want to see in first BSc how many number of doing this nurse degree course for the first BSc, how many number of people are there, strength of people. Like suppose red is for girls and B is for boys. So in first BSc, how many number of girls are studying first BSc, and in how many number of boys are studying first BSc. Like this within this bar, I have to represent it. So that should be this sample bar, or that should be converted to stacked bar or proportional bar diagram. So next one is the percentage bar diagram. So to represent these items whose magnitudes have two or more components, the comparison of components are expressed as percentages of the corresponding totals. So the totals are going to be represented by bars of equal width and height that should be equal to 100 each. And these bar diagrams are divided according to the percentage components, and different subsections have to be shaded properly. An index which describes the shades is provided. Okay, so this is the percentage bar diagram. So in percentage bar diagram, the bar is completely matched with the 100%, and then each component value how it will be. Suppose it is 60 and this should be 30 and this should be 10%. The sum of the components of that each single bar that should be matches to 100%. That should be the percentage bar diagram. Okay, so the totals are represented by bars of equal width and height should be equal to the 100. That should become able to call it as a 100. Suppose similarly, if I'm going to take the women as criteria, so within this it should be matches to 100. So within that, how many number of girls, women are doing practice in dance, that will be 70%. How many number of women are seeing watching TV 10 and sports. So some of this will be the 100%. So how many another example? So food component and rich component I'm taking. So how percentage energy that is obtained through fat should be the green color, and percentage of energy that is obtained through protein is red color, and blue is the color. The percentage energy that is obtained through carbohydrate. Like this, I can able to create it for the match of 100%. And next one is that multiple bar diagram. So in multiple bar diagrams here, whenever the two or more different comparisons, comparable set of values are going to be drawn, then import and exports. And here the set of rectangle bars of equal length being proportional to the value are going to be drawn, and the bars corresponding to the same unit are going to be placed together adjacent to one another, and the diagram is going to be shaded different properly, and the index is going to be provided. So within this, I can able to know in 2009-10 sales division I wanted to present it, and we taking a year. So within this, how many number of sales that is going done in north side and south side, east side and west side. So this type, if I want to represent it, then you can able to show through the multiple bar diagram or component bar diagram. See the example. Similarly, in previously I shown within the single bar. Now how can I able to represent this? So the number of boys and girls studying in first BSc, number of boys and girls studying second BSc, third BSc, and fourth BSc. I can able to find it out. So for that, I can able to present a single bar. I can able to show, or I can able to show through the multiple bar. But which one is the best thing? You have to be identified. And next one is the deviation bar diagram. So deviation bar diagram means we can have negative values in the sense negative values as well as positive values. So if I'm going to take positive and negative values on the y-axis and then a, b, c, some other factors I'm taking on x-axis. So the whole values should be greater positive. That should be positive deviation, and the bar diagram that comes below 0%, that should be negative deviation. So most of the time this kind of graph you can able to see in stock markets like this. So Sensex likes. So some of the variations, suppose administration, nursing, pharmacy is there, an actual thing, and budgeted, and variance. So here, if I'm going to calculate this variance, I'm getting the minus values as well. So for that, so administration how it will be 25. So I can able to get positive deviation. For nursing, it should be minus 20. So the line, the bar that should becomes below this 0. So that's one you can able to call it as negative deviation. So similarly, pharmacy minus 5 and plus 5 and plus 10. So this kind of we can able to call it as deviation bar diagram. So this is the other kind of example. And next one is that other presentation of data what we are having should be stem and leaf. Stem and leaf plot is a quick way to organize the large amounts of data, and special table where each data value is split into a leaf and a stem, what we call it as that, and the stem values are listed down and leaf values are going right or left from the stem values. So the stem is the thing is used to group the scores, and each leaf indicate the individual scores within the each group, right? The special table where each data value is going to be split into two values, right? So left leaf and then stem. So leaf will be the last digit and stem will be the other digits, right? So see this pulse rate I'm taking. So 19 samples I'm taking. So before 6 years age of people, the pulse rate will be before 8, 9, and after 8, 9 or 10, and some age people this will be before, and after it will be this. So at the age of 9, the pulse rate is 60. After that it should be increasing. So this one you can able to call it as the stem leaf graphs. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.